we have a very special highlight. We have Daniel Myers, who's a senior developer relations expert at Snowflake, and who has a storied career in technology. So he's before been at world-renowned companies like Cisco and Google, but he has also been a successful startup founder, and he's one of the rare people that have been both successful as a technologist as well as building businesses. And as you all know, Snowflake is at the center of like many of the unicorns and big startups being built. So he's going to talk to you about the development journey and the evolution of data apps. Please welcome our friend here to Cluj. Thank you so much.
Thank you.
Thank you.
That was an amazing introduction there. So, as you said, my name is Daniel Myers, developer relations here at Snowflake. To kick this off, I want to everybody here, raise your hand if you are a developer, software engineer of any kind. Awesome. Raise your hand if you are building a business, a founder, VC, business manager. Awesome, awesome. So today's talk is all around building data applications and how they've evolved over time. A little bit about me, as you said, spent time at Google, Cisco, Fujitsu, founded multiple startups myself, and inventor of 3 different patents. So for data applications, it's important that we all have a common definition of what a data application is. At the end of the day, all applications use data in some way, shape, or form. And it's really more about how that application is using that data, how much data and how data intensive is that application, and really how data is used to solve the problem that application is built to do. And so with this common definition, let's look at a few use cases for data applications today. One that we see a lot at Snowflake is Customer 360. The idea that you want to get as much information about your user, about your customer, to make their experience better on your platform. It could be building a product recommendation engine. Think e-commerce. It could be using and helping prioritize internally what features to build next in your application based on user behavior of your application. The other big use case that we see a lot is the concept of Internet of Things. Millions or billions of sensors globally. You are ingesting that data, you are analyzing that data, and you're doing something, you're taking action on that data. Maybe you are doing predictive analysis on when a device may need maintenance. And so you want to preemptively fix a device or replace a part before it actually breaks. Next is machine learning data science. So building, training, deploying ML models, being able to do that on Snowflake, and using those models to solve real-world problems. And then lastly is really app health and security analytics. So this is the idea that every application themselves are creating an immense amount of logs, data, that can be used for security analysis, network penetration, etc. And across all of these, we see what's called embedded analytics. So where really the idea is that no matter what the application does, it could be a ride-sharing application, there are pieces, different features within that application that need and require an immense amount of data to solve and provide that data back to the user. Case in point with providing an estimated time of arrival in a ride-sharing application. You'll need data around current traffic trends, the current weather, and how that's affecting travel destination times to different locations. So with the evolution of data applications, it's also important to know and understand how data management over time has evolved. And so this diagram here shows really 3 main areas where it has evolved over time. Originally, table-based data, where you are doing joins, very structured. We call this structured data at Snowflake. So you are predefining schemas, you are designing tables, joining tables together to get that data. Next is really semi-structured data, so file-based. It could be JSON documents, it could be XML, Avro, etc. And what you need to be able to do is use data from table-based paradigms and semi-structured data together. So you need to be able to join just as you would the table-based data with semi-structured data. Now fast forward to today, and where we're continuing to move to, is the concept of truly borderless data. This is the concept of that data could be living in an S3 bucket somewhere, some random REST interface on the internet, but what you need is a common unified interface for querying, moving, managing access to that data, and you need to still be able to join that data at query time with all of the other data that you have. So table-based data with this borderless data that's sitting in a PDF file on an S3 bucket somewhere, right? You need to be able to extract data from that PDF, join it simultaneously with data that you have in a table, and join it with some information that's in a large JSON document. You need to do all of that simultaneously. So when we look at the lens of a developer, and when you're developing an application that is data intensive, there are really 4 buckets of considerations that you need to be aware of when deciding which platform to use and how that impacts your architecture, your go-to-market as a business, and what actual features that you'll be able to implement in an easy way. First is continuing on that concept of truly borderless data. You need a platform that can actually ingest and query all of that data no matter where it lives. Snowflake can do that. Next is coding the same way, executing faster. This is the idea that as you build your application, different developers, different businesses obviously build their applications using different languages, whether it's Python, Node.js, PHP, Go. You want to be able to use a data platform that helps and hooks into the language of your choice. And at Snowflake, we call that extensibility. So out of the box, you need a way that you can leverage the language of your choice while still leveraging the power, the performance, the scale of a data platform. So in this case, for example, we have what's called Snowpark. It's the idea that you can create, you're given an API and a framework. Today we support Python, Java, Scala. And you can build this application locally on your machine, but the actual compute is happening inside of Snowflake. So you get the query optimizations, the scale, and massive parallelization that Snowflake provides out of the box. While at the same time, you get to leverage and use Python, for example, to do that in a data frame type of format. Very powerful. The next big consideration is around creating and maintaining your dev environment. Show of hands, who here uses live production data in your development environment when testing? Awesome. So with something like Snowflake, we support what's called zero-copy cloning. This is where you can have live queryable data up to date without actually having to take a snapshot of what's in your data store and cloning it. This is zero-copy clone, so it's literally providing a pointer to the same data on disk. Now, naturally, a lot of people instantly ask, well, what if I do an update or a new insert? The beauty with something like Snowflake is it's all change-based. So if you make an update in the dev environment that's pointing to prod data, those changes are separate. So you can maintain two divergent courses of action, one in prod, one in your dev environment. That is incredibly powerful when it comes to not just testing and building a new application, but also for other teams in your organization. For example, maybe you have a data science team or an ML team that uses data from the application, that you're always ingesting data from users, and you want to continuously train a model. You can do that with a setup like this. And Snowflake is what powers that. So the last bucket, and really, in my opinion, one of the most impactful areas, is the need for access to live, share live, ready-to-query data. This, for example, well, let's take the ride-sharing application again. Is your ride-sharing app going to have all of the weather information? Is going to have its own fleet of sensors for weather data, or are you leveraging a third-party service for that weather information? With something like Snowflake's data marketplace, you have, instead of having to create a API transformation layer with a third-party API weather service, you have that weather data live, ready to query, up to date instantaneously within your Snowflake environment. So you can do those SQL queries directly on that live weather data without having to extract, load, transform it anyway into your app. It's just ready to query live. That's huge. You also have the ability to share compute resources, as in small pieces of functionality. We call them UDFs or external functions and things like that that you can share. These are small, think of, so what is an external function for Snowflake? An external function is literally a AWS Lambda, a GCP cloud function that you can call directly from a SQL query on your data and have it process data within Snowflake. With Snowflake, the concept here is that you have a unified access user management layer that you can have governed across all of your compute, all of your data in a single place. So, what are the different types of data applications today? There's three main types. One is the managed app. When you think of a traditional SaaS application, the majority of them today, especially if they are consumer-facing, so not B2B, but consumer, they're going to be a managed application. That's the idea that the builder, the builder of the application, company A, owns and manages the data that is within that application. So they're both the hoster of that data, they maintain the structure of the data, they define what the data is. Next is the concept of a connected application. This is where the builder, company A, actually connects to their customer's data location. Why would you want to do that? Several reasons. One, this gives the power to the customer to be able to join that data later with other data that they may have. You'll see this a lot of times with audit logging applications. If you are an application that does auditing of user access, well, the customer that you have also wants that raw data as well. They want to be able to join it with other relevant data that they may have about internal users, things like that. Same thing with any information that a customer would want to leverage to build and join with other data that they have in their environment. The third is what we call a native application, Snowflake native apps. This is where the actual compute, the actual application is running inside of the customer's environment. So how is this different from a connected app? The connected app, the compute is running inside of company A. Your application is running outside of the customer's environment. With a native app, you bring that compute closer to the customer's data, literally inside of it. And why would you do that? It provides a few programmatic guarantees to the customer. One, it means that the customer's data literally never leaves their environment. So you can have an auditable trail of what has accessed that data, what has used it, and where it has been. So let's actually take a deeper dive into each one of these and look at some reference architectures and example customers. So the managed app, high-level block diagram here. Your SaaS provider code is owning and managing all of the data. It processes the customer's data in its own data platform, right? This is really a best fit for if you have a really large number of customers, largely consumer-facing applications where your customers may have a small piece of the broader amount of data. A referenced architecture for this, you can see a couple key points that I want to point out in this diagram. One is you have a hybrid approach. You have your operational data. So this could be your OLTP database, NoSQL, doing an ETL into Snowflake, for example. You also have your streaming services and your cloud object storage being loaded directly into Snowflake. And the apps that you're building are doing direct analytical queries on top of Snowflake. And so now let's go one step further and compare this to the connected app. So the connected app, the block diagram changes a little bit. You have your SaaS provider code that's connecting to the consumer, to your customer's data in their environment, right? And so it's storing and processing the data not within its own environment, but within the customer's. And then the actual compute and storage costs are also associated with the customer there. So that's a business use case difference, is who is paying for the compute and who is paying for the storage of data in this environment. This is really a best fit when you have a B2B type of environment. So a large business that wants to maintain some control over their data, that wants to join that data with other data that they have across their business. So a reference architecture here. Big difference here is that you see two outlined boxes. One on the very left side, number 3, is the builder. So this is the SaaS provider is doing a data sharing directly into the customer, the box number 2, into their environment. And you'll notice that the customer is the one that's doing the batch data loading into theirs. They're also doing the event data directly into theirs. And this is really where, between the SaaS provider and the customer, there is some connection between them that they have to coordinate what the data model looks like so that the SaaS provider can operate on it. So there's some coordination between the customer and the SaaS provider in this scenario. Let's go to the last one here, native applications. So a native app is really the newest and really where there's a large paradigm shift. And you'll see here in the block diagram, all of the native app code is running inside of Snowflake. So you have one set of data, the customer's data, and you have your native application code running inside of your customer's environment. And so this ensures, programmatically guarantees that customer's data never leaves the customer's environment. This is huge when it comes to regulatory requirements, and some customers, that's simply what they want. They require that because it could be something very, very special to their application. It also means that you can operate on this data without actually knowing necessarily what that data is. So that the SaaS provider in this case will never be able to extract any metadata information about the data, et cetera. This is a best fit when you have 100,000 plus customers. You're targeting, especially if you have Snowflake customers already, this network effect. You can run native applications. This is something that we just announced actually 2 weeks ago at the Snowflake Summit in Vegas. Now, let's look at the reference architecture for native apps. What we have here is the marketplace data, right? So you can have a marketplace of data, a marketplace of applications, and the customer can install your application directly in their environment. And you'll notice here that it has access, that native application is given a framework, a software framework for Snowflake primitives like UDFs, stored procedures, sharing. And so at the base layer, we're using the same technology as that zero-copy cloning and that sharing capability. But it's done in a secure way where the customer has complete control over what's accessing and managing their data. And so you'll see here that native apps can leverage data shares from the marketplace. So it can join, for example, that weather data. If you are, what's an example of a native application use case? Let's say you have an application that does automatic tagging of PII information, so personally identifiable information that a customer needs to automatically tag all of the data in their data cloud. A native app is a perfect use case for that because the data doesn't need to leave the customer's environment. You can run ML models directly inside the customer's environment. And you can join other data sets, for example, weather data, stock data, a lot of different data sets. Definitely check out the data marketplace on Snowflake. But the idea here is that you can leverage this, run it directly inside the customer's environment. So let's look at all three of these kind of side by side. You have a tenancy difference between them. What is tenancy? It's the idea that you have multiple users or customers within your application. How do you reference multiple? So MTT is a multi-tenant table. This is something that you see a lot with managed applications. So you have a single user table and all your users are in that table. You also, in Snowflake, you have the concept of object per tenant or account per tenant. So you can isolate your customers in completely different environments and provide that next layer of isolation. And so in addition to these reference architectural differences, you also have the business implication differences for who gets charged for compute and storage, and how you want to go about that. And so with that, I want to say thank you. My name is Daniel Myers, Developer Relations at Snowflake, and it's been an amazing time here in Romania. Thank you.